In this video, we're going to be working AP Pre-Cal Homework 3-4, and it's mostly polynomial long division, but also talking about in behavior of rational functions that have degree of the numerator exceeding the degree in the denominator. So we're going to see bigger on top, like a lot here. Okay, so these first ones is like, hey, just describe the in behavior based on the degree and leading coefficient of the polynomials in numerator and denominator using limit notation. So just like we did before, we're going to take the biggest term from top and bottom and we're going to divide them, and that will give us our end behavior. We're considering 3x to the 3 over 1x. So that's equal to 3x squared. Okay, so the end behavior of f of x is going to be the same as the end behavior of 3x squared, and we know what 3x squared looks like. Okay, both sides of the parabola open up. It's an even degree polynomial with a positive leading coefficient, so we'll say the limit of f of x as x approaches positive infinity. That's going to be positive infinity, and so is the limit of f of x as x approaches negative infinity. Okay, both will be positive infinity. Alright, for this one, I'm looking and I'm probably, it's not always going to be, laid out so that the leading terms are like right above each other, right? So I should probably just identify which ones I'm looking at here. The highest exponent is the negative 2x to the 5 and the negative x squared. So the end behavior is going to be determined by negative x to the 5 divided by negative x squared. Okay, so negative 2 divided by negative 1 is positive 2. X to the 5 divided by x to the 2 is going to be 3 powers of x. So the end behavior of g is going to be the same as the end behavior of 2x to the 3, which is like that. So we'll, write in our limits. X approaches positive infinity. Off to the right, g of x is also approaching positive infinity. And then as x approaches negative infinity, as we move to the left, g of x is also going to be approaching negative infinity. All right, on this one, h of x equals x to the 3 minus 5x divided by 3 minus x. Okay, kind of the same thing. We're going to identify the biggest term on top and bottom. It's x to the third and negative x. So the end behavior is going to be determined by x to the third divided by negative x equals negative x squared. Okay, so that's a downward facing parabola, so both of the limits are going to be negative infinity. Okay, alright, so wait, no, there's one more of these. Alright, so the last one is 3x squared plus 5x plus 2 over x minus 5. This one's bigger on top by exactly 1, so there's going to be a slanted asymptote, but we're not really interested in the equation of the slanted asymptote right now, just the end behavior using limit notation, so 3x squared divided by x. So if I take 3x squared and divide by x, that's going to be 3x. And what we learned was that, the slanted asymptote is going to be parallel to the line of y, to the line y equals 3x. It's going to be 3x plus something else probably. And we could find the equation of that using polynomial long division, which I'm sure we'll be doing here in a minute. All right, so y equals 3x, we know that looks like this, a line with positive slope. We're interested in the end behavior, so the limits as x approaches infinity and negative infinity. As x approaches infinity, j of x appears to also be approaching positive infinity, right? I'm going up here as I go to the right on the line. Then as I go to the left, I'm going downhill, so the limit of j of x as x approaches negative infinity is going to be negative infinity. This one is like, hey, here's a rational function. What are all of the asymptotes? Okay, so find the vertical asymptotes, horizontal asymptotes, slant asymptotes. Like, we're not going to have both horizontal and slant, but this is kind of the type of question we're preparing you for. It's just like find all the asymptotes scenario, which could really easily show up in multiple choice, right? All right, so if we look and we're thinking about, all right, maybe simplify first to try to identify any holes. Okay, well, x squared minus x minus 14. The only numbers I can think of that multiply to 14 are 7 and 2 and 14 and 1, and neither of those add up to negative 1. So I don't think that's factorable. So I don't think I'm going to be able to cancel anything. So I'm going to say, all right, there's a vertical asymptote at x equals negative 4. And then since the degree on top is 2 and the degree on bottom is 1, it's bigger on top by exactly 1, there's going to be a slanted asymptote. And so I'm going to need to find that using polynomial long division. Okay, now I'll do this a different way. And this only works for when it's degree 2 divided by, I'll do synthetic, right? But that'll only work when it's degree 2 divided by degree 1 and the slope of the degree 1 in the denominator is 1. So it's not really a technique with all that much longevity. Overall, for us, polynomial long division is going to be much safer. So I take the first term out front, that's x, and I say, what do I have to multiply this x by to get x squared? And that would be multiplying by x. Okay, and then, when I actually do that, I take the x and I multiply it back around by the x plus 4 and copy down the product here. That's x squared plus 4x. Okay, just like when I'm long dividing numbers. Okay, then what I do is I subtract this down. I have, okay, x squared minus an x squared is 0, and negative x minus 4 more x would be negative 5x. Okay, then we drop down the negative 14 and repeat the process. Zoom out and give myself a little more room. I say, what do I multiply this x by to get this negative 5x? And that would be a negative 5. And then I multiply the negative 5 down by the x plus 4. We'll copy that in. Negative 5 times x plus 4 would be negative 5x minus 20. Now, if I'm going to subtract that, that's going to be like adding the negatives. So I'm just going to add down. Negative 5 plus positive 5 is going to be 0, and negative 14 plus 20 is 6. Okay, now that I've gone this far, the 6 is going to be my remainder. Okay, so it's going to be x minus 5 plus 6 over x plus 4. And that's just a different way of writing g of x. I might call that like mixed number form, or, I forgot what I called it last year in Algebra 2. I saw that in a textbook this year, mixed number form. I'm not sure I would call it that, but what I'm saying is that x minus 5 is the equation of the slanted asymptote, and 6 over x plus 4 shows you where the vertical asymptote is. Okay, so I'll go off to the side and say the slant asymptote is y equals x minus 5. And I'm sure I discussed this in the lesson, but you can see that y equals x minus 5 would be the slanted asymptote to the graph of g when you write it in that simplified form, that divided form, because 6 over x plus 4, that's the type of fraction that the bigger x gets in the positive or negative direction, that fraction is going to get closer and closer to 0. So overall, g is going to get closer and closer to x minus 5. And so that's what it means to be an asymptote, is something that the function is getting closer and closer to being. It's just, in this case, it's not a constant number, it's a line. Alright, this next one, we're going to do the same thing. It kind of looks like maybe I could factor and cancel some stuff, so I'm going to try to factor it, and I'd get, what's that going to be, x minus 2x plus 1. And then we're dividing by x plus 2. So I'm not going to be able to cancel anything off, so, okay, that was not fruitful, but, worth a check. Okay, that means I'm going to have a vertical asymptote at x equals negative 2. And since it's bigger on top by one factor, I'm going to do long division. I just realized I said I was going to do synthetic division on the other one, and I didn't. So I guess I'll do that on this one. But this one, again, I'm going to always default to polynomial long division because synthetic won't always work for us in this class. Because what if we have to divide by 2x plus 1? Or what if we have to divide by x squared plus something and we had degree 3 on top? Those would be perfectly valid scenarios that could happen in AP Pre-Cal, and we got to be ready for those. All right, so what x times what is x squared? That's going to be an x. Multiply that down, that's x squared plus 2x, subtract, get negative 3x minus 2. So I got minus 3, negative 3x minus 6. If I'm subtracting this, it would be like adding negative, or yeah, subtracting negatives is like adding. Go over here, negative 2 plus 6 is 4, and that's going to be the remainder. Okay, so that means that I've got a slanted asymptote. Y equals x minus 3. Just this part here that's it's not got the fraction on it. That's the equation of the slanted asymptote. All right, now I almost forgot again. If I go over here and I set up for synthetic, which if you didn't learn this in Algebra 2, no big deal. That's just not going to be part of this course because we just don't need to do this all this often. And definitely not dividing by x plus 2. What we do is, run this through synthetic division. Let's see, 3 times negative 2 is 6, 6 minus 2 is 4. You can see we're getting all the same numbers. Same idea. It's that v of x equals, this number is your remainder. So that's the remainder, that's the ones, that's the x's, and then x squared and x3 and stuff would keep going if we had more factors. So it's going to be 1x minus 3 times 1 plus 4 over x minus negative 2. And just like that. And so that's how you would get the same division using synthetic, which is a little bit faster, but it won't work on the next one. I am seeing that the denominator of this one's factorable. It won't work on this one unless one of those factors of the denominator is also a factor of the numerator, which I somehow really doubt. I'm trying to think how we would know that. Absent factoring, we'd have to be able to see. We'd see something when we would do the long division, which we're definitely going to do. Okay, so let's just get into it. Let's assume there's no holes, at least at first. We'll say the vertical asymptotes. We're going to need to factor the denominator. Maybe I'll do that over here. X squared plus 8x plus 15. That's going to be 5 and 3. X plus 5. X plus 3 equals 0, so that would be x equals negative 5, and also x equals negative 3. Assuming that those aren't also factors of the numerator. Okay, but then to find slanted asymptote, because I've got degree 3 on top and degree 2 on bottom, I'm going to say, all right, do some polynomial long division here. So negative 2x cubed, negative 15x to the 2, negative 22x, and positive 15, and remembering that we would need to put in a 0 for any missing powers of x. I haven't seen that happen yet on this homework. I'm pretty sure it happened on the notes, though. Okay, and then I'm dividing by x squared, 8x, and positive 15. Okay. Now I'm saying, what do I multiply x squared by to get negative 2x to the 3? That would be negative 2 and an x. So I multiply the negative 2x down over this whole divisor and get negative 2x cubed, negative 16x squared, and negative 30x. Okay, so that's kind of nice. Wait, that's going to subtract. I need a lot more room. Okay, so we're going to subtract this all away. Okay, subtracting, I'm going to turn into addition because these were all negatives. Okay, and then I'm going to say 0, positive 1x squared, and positive 8x. And then what do I multiply x squared by to get x squared? That would be positive 1. And actually, I'm good here at this point. I don't really need to, I probably should have dropped down that 15. I don't need to multiply it across because this is going to be the equation of the slanted asymptote, but I'm just going to take the long division the rest of the way through just to show you. 1 over, or multiplying that by 1, x squared plus 8x plus 15. Oh, okay, yeah, no remainder. So that must mean that it was a factor. Okay. And maybe that was intentional. So what this is going to be, let me just double check this. All right, there you go. So I just checked it with synthetic and I got, both no remainders. So that means that both of these things are a factor of the original. And so that means that I don't have any vertical asymptotes. These are holes. And I'm not sure if I would describe y equals negative 2x plus 1 as a slanted asymptote to the graph of f, because really f is just y equals negative 2x plus 1 with a couple of holes in its graph. So, and I don't think that that distinction is something that they're going to be getting into in AP Pre-Cal either. The difference between a line with a hole and the slanted asymptote, no big deal there. Right, I think really what that was getting at was the idea that if there's no remainder, then the divisor is a factor of the numerator. So if r of x equals f of x over g of x has a slant asymptote of y equals 4x plus 5, or minus 5, and the function f is 2, 12x to the 3 minus x plus 11, what's the degree and leading coefficient of g? All right, so what we know here is, all right, r of x is equaling f of x, which is 12x cubed minus x plus 11 divided by g of x. Okay, and then it's gonna be, if it's got a slanted asymptote of y equals 4x minus 5, then, well, I know that it's going to be r is a bigger on top by 1 type rational function. So I'm going to have x squared there, but I'm really going to have some other number of x squareds. Remember that thing that we said about the end behavior of a rational function is that, if the quotient of the leading terms is a linear function, then the slanted asymptote will be parallel to that line. So we need it to be y equals 4x, or we need this end behavior thing to be 4x. So basically 12x cubed divided by some number of x's needs to equal 4x. Right, that's our idea here. All right, so it looks like we're going to need to divide the 12 by a 3 to get that 4x. Okay, so I'm going to put the 3 in there, and as a result, I know that I'll have g of x being 3x squared plus some other stuff. And, we don't want to get into how the long division is going to work out. I'm sure we could figure it out, right? We've got y equals 4x minus 5 plus other things that are kind of less important. We could probably figure out most of g of x, maybe not the constant term of g if we weren't sure what the remainder, for the numerator the remainder was, but that's not important. I think we're going to say our degree is got to be 2 and the leading coefficient. So it'll be 3. All right, another one. I think this is exactly the same. R of x equals 4x to the 4 plus 3 divided by g of x. So we gotta think about what would be the degree and leading coefficient there to make the end behavior equal to negative 2x. All right, so I've got 4x to the 4 divided by what? Okay, some number of x to the thirds. And what number would be negative 2? Yeah. All right, so negative 2x to the third plus who knows what else, but that's not what matters. They're asking for the degree and leading coefficient. So the degree is going to be 3 and the leading coefficient will be negative 2. Right, now combine the rational expressions and describe the end behavior of f. All right, so what we're going to do is we're going to write these with a common denominator and then do the same thing that we did in number 1, just analyze the leading terms in the numerator and the denominator. All right, so these have different denominators, so I need to just multiply by the opposite one. So x to the third over x plus 3. I need to multiply by x minus 2 on top and bottom. Minus 1, and then thing. I've got x minus 2. I need the x plus 3. I need to multiply by that on top and bottom, so I'm multiplying by 1 so I don't change the value of the fraction. Okay, so that's equal to this, and then I'm going to do the distributions. Let's say that's x to the 4 minus 2x cubed minus the x plus 3, 1x plus 1, 3 over x plus 3 and x minus 2. Right, and then, okay, I'm gonna need, if I want the end behavior, I want this like distributed out, not necessarily factored. Okay, so, but I don't need all of the terms, right? I really just need only the highest power terms, but I'm gonna just, because I can, write them all out. X to the 4 minus 2x to the third minus x minus 3. Dividing by x squared plus x minus 6. So to determine the end behavior, I need to look at the leading terms ratio. So let's see over here. Behavior will be determined by x to the 4 divided by x to the 2, which equals x squared. We know what the graph of y equals x squared looks like that. So we'll say the end behavior with limits. Say as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f still approaches positive infinity. Because overall, it's got like kind of a parabola-shaped asymptote. All right, now this one says, all right, if we've got f of x over g of x, describe the shape of the end behavior. Like basically, does it have a horizontal asymptote of y equals 0? Does it have a horizontal asymptote of y equals some non-zero constant? Does it have a slanted asymptote? Does it have a parabola-shaped asymptote? Or does it have like a cubic-shaped asymptote? I don't know if we looked at any of those, but it would happen if we were bigger on top by 3. All right, so if we have the degree on the bottom is exceeding the degree on top, bigger on bottom, that's where we'll see, the rational function goes towards 0. So we'd say y equals 0 as our asymptote. What's that going to be? Oh, yeah, A. Degree of f is 2 and the degree of g is 3. That's the only one where g is greater than f. Yeah. So that's a y equals 0 horizontal asymptote. Okay, the degree of f is 3 and the degree of g is 2. Okay, that's going to be where I'm bigger on top by 1, so that's going to be a slanted asymptote, or a linear in behavior. Maybe I'll write linear. I don't know what exactly we're looking for here, what we're gearing up towards on the test. I'm not exactly recalling what this question is getting at. The degree of f is 4 and the degree of g is also 4, so we've got equal degrees. That's where we're going to see y approaching some constant value that's given by the ratio of the leading coefficients. So y equals some non-zero constant horizontal asymptote. Then the degree of f is 5 and the degree of g is 3. So we're bigger on top by 2 now. That's going to be a parabolic asymptote, which is like quadratic in behavior. And then if the degree of f is 4 and the degree of g is 1, I'm bigger on top by 3, so it's going to be cubic asymptotic, cubic end behavior. I don't know. That's a pretty extreme situation. I'm not sure I have seen one of those before. Alright, let g of x, and this is the last one, be 2x to the 4 minus x to the 3 minus 4x to the 2 plus 9x plus 9, 4, 3, 2, 1. Okay, so no missing terms. So this homework definitely is missing that. It's too bad. We'll probably make sure to put that in the practice problems. Determine whether p is a factor of g, and determine whether g over p has a slanted asymptote. Okay, yeah, I remember about this. Okay, so if we're going to determine whether p is going to be a factor of g, we're going to need to do long division, and if the remainder is 0, then it is a factor. All right, so that's what we're going to be I'm working off of. That's the key fact. So I'm going to set up for some long division here. Actually, I don't know that I can. So I'm doing the long division, and one of my best pieces of advice for doing polynomial long division is to just space out your work. So many of the errors come from either like not having the stuff lined up, or place value, or just overall sloppiness that could be avoided, not necessarily by going any slower, but just taking up more space with your work. Okay, so ask yourself, what do you multiply 2x by to get 2x to the 4? That's going to be x to the 3. Then I multiply that down. X to the 3 times 2x, 2x to the 4, positive 3x to the 3. I'm going to subtract both of these things, and then, let's see, I get 0 and negative 4x cubed. Okay, so 2x times what is negative 4x cubed? That would be negative 2 and an x squared. Okay, so I take the negative 2x squared and I multiply it down by the, I guess I need to drop this as well. So negative 2x squared times 2x, that's the negative 4x cubed that I needed. And then I multiply by positive 3 and I get negative 6x squared. Yeah, I'm subtracting this, so if I'm subtracting a bunch of negatives, that's just like adding. And I'm going to need to zoom out a little bit. I'm going to get 0 plus 2x squared, and then I'll drop down to 9x. Put that in there, and say, all right, now what do I multiply 2x by to get 2x squared? That's positive x. And then x times 2x is 2x squared plus 3x, and then we subtract that. This one just keeps going. And I'll have 0 and 6x. And so I'm going to add 3. Okay, this one is looking like it's going to divide cleanly, because the next step, I'm going to drop down that 9, but 3 times 2x plus 3 is 6x plus 9, and I end up, off the screen again, but I end up with remainder 0. Okay, so I can say that, yes, this p is a factor of g. And no, it's not going to have a slanted asymptote because it's that clean division, and also it was bigger on top by 3 factors. It was fourth degree divided by first degree, so it was going to be one of those with a cubic type asymptote. But basically, I'm saying, like, yes, it has a slant. No, not. Yes, it's a factor because of that 0 remainder right there. So we divided it, came back clean. That was more than enough long division. That was a long one. And I should probably also just write in clearly that the slant asymptote is a no. But let's move on to the other p of x. Alright, so for this next one, we're going to divide by x to the 3 plus x to the 2. And I'm thinking this one's probably going to be a slant asymptote, yes, because dividing degree 4 by degree 3. So if I see not a 0 remainder, which would make a lot of sense if I was going to give you 2 of them, one had yes already, and the next one probably had no. Wait, but that was not x to the 3 plus 2. That's going to be x to the 3 plus x to the 2. And that will make a huge difference. Okay, so I'm asking myself, what do I multiply x to the 3 by to get 2x to the 4? That'd be a 2 and an x. So I'd have 2x to the 4 here, plus 2x to the 3. Subtracting these, I'm going to get negative 3x cubed. I drop down that negative 4x squared. I say, what do I multiply x to the 3 by to get negative 3x to the 3, and that would be a minus 3. Okay, so 2x minus 3 is probably going to be my slanted asymptote. And then I will multiply the 3 over the x cubed, or the negative 3 over the x cubed, and the positive x squared. And I'll be subtracting that, but since I'm subtracting a bunch of negatives, I'm going to turn those into pluses. And then I'm going to have negative 4x squared plus 3x squared is still negative 1x squared. And since, you would like drop down the 9x and I guess the plus 9 as well, and once you ask yourself, what do you multiply x to the 3 by to get negative x to the 2, that doesn't make sense, right? That's out of bounds. So that means you're done, and then that's your remainder. So I've got 2x minus 3 plus, or yeah, I'm just going to do plus, and then just write the remainder as I see it. Negative x squared plus 9x plus 9. You could write it as minus x squared minus 9x minus 9 in the numerator, but the original minus being on the outside, but that's just a little bit more than we need, I think. Divided by x to the 3 plus x to the 2. And notice the fraction is still the type of thing that's going to go towards 0 as x approaches infinity or negative infinity because it's bigger on bottom fraction. All right, so I'm going to say, is p a factor of g? No, definitely not, because I got a non-zero remainder. No for being a factor. For slanted asymptote, I'm going to say yes, because I can see that the slant asymptote, that's a yes because it's y equals 2x minus 3. I can actually see it from my long division. Okay, so that's my answer there. And I think, yep, that is all for this homework. So that's going to be all for this video. Thanks for watching.